So section 1.1 deals with points and lines in the plane. We're going to start out with some vocabulary that deals with plotting points. We've got the Cartesian coordinate system, which is a system designed by René Descartes. It deals with your x and y axis, which are perpendicular on the coordinate plane. So our x-axis is our horizontal axis, and the y-axis is the vertical axis. A quadrant is exactly what it sounds like. It cuts the coordinate plane up into quarters. So if you scroll down a little, we've got the Cartesian coordinate plane broke up into quadrants. We've got quadrant 1, which starts in the upper right hand corner, and it goes counterclockwise to quadrant 2, quadrant 3, and then all the way around to quadrant 4. Right there in the center, where the two axes meet, is the origin. That's the ordered pair 0, 0. That's basically your starting point. If you're plotting any points, you're going to start at the origin. And then your x coordinate is the first coordinate in your ordered pair, and it runs horizontally, so left to right. The y coordinate is the second coordinate, and it runs vertically, so that's up and down. So when you're plotting ordered pairs, you move left to right first, depending on if it's positive or negative, and then the y coordinate, you go up or down. If it's positive, you go up. If it's negative, you go down. And that makes the ordered pair where x is the first coordinate and y is the second coordinate. So if you look at your coordinate plane in quadrant 1, any point in quadrant 1 is going to go to the right for your x coordinate, which would make it positive, and up, which would make the y coordinate positive. In quadrant 2, you would have had to go left first, which would make it negative, but then you would go up for your y coordinate. So any ordered pair in the second quadrant would be negative, positive. The third quadrant, you'd go left and down, which would make the x and the y both negative. And then in quadrant 4, you'd move right for your x coordinate, but down for your y coordinate. So that would make it positive, negative. Now be careful when you're plotting points. You always move left or right first, and then up or down. Unlike slope, which we'll get to later, a slope is rise over run, where you go up or down first and then over. Don't get those two confused. If you're plotting points, you go left to right first and then are up or down. So let's practice that. We've got point A right here at the origin, so it's coordinate 0, 0. Point B, we've going to the left 1, so that's negative 1, and up 4. C is going to be, now be careful here, C, we haven't gone left or right, so that x coordinate is 0, and then you've gone up 2. D, you've gone right 2, up 1. E, you've gone to the left 3, so the x coordinate's negative 3, but you don't move up or down, so that y coordinate is 0. F is to the left 2, down 3. And then G would be right 1, down 1. So just be careful about that. It's not that hard, but you just have to be careful that you move the x direction first and then the y direction. Okay, now let's talk about the distance formula. The distance formula is actually derived from Pythagorean theorem. Which, if you recall from geometry, is a squared plus b squared equals c squared, where c is your hypotenuse of a right triangle. So I'm just going to pick any 2 points. They can be points anywhere on the graph. And since they can be anywhere, I'm just going to label them x1, y1, and x2, y2. I don't want to put specific coordinates there because this works for any 2 points. If I want to find the distance between those 2 points, I can make a right triangle if I connect them like the 2 points like that, where let's call this A, this B, and then our hypotenuse is C. So this is our right triangle, and we've got A, B, and C, where C is the hypotenuse. So if we want to find C on this, A squared is going to be the distance from this point to this point, which to find that, you're going to subtract the x coordinates. So I'm going to have x1 minus x2. That represents A. So if I'm plugging that into Pythagorean theorem, I've got x1 minus x2 squared plus B is going vertically, so that's going to be our y1 minus y2. So y1 minus y2 represents B. So we've got to square that, and that equals C squared. So this is Pythagorean theorem, but it's written in point form. So if I want to find C, I'm going to square root both sides. And that formula right there is the distance formula. It's the square root of x1 minus x2 squared plus y1 minus y2 squared. That's how you find the distance between 2 points. Now, it doesn't matter which one you put first, x1 or x2, because those are just labels. I could have easily labeled this one x2, my point 2, instead of my point 1. You will get the same answer as long as whatever you use for x1, you use the same value for y1. Just make sure your points line up. So let's look at an example of finding the distance between 2 points. Now, it's not necessary to graph this, but it always helps to have a visualization. So we're going to do -3, -1 is our first point, and 2, 3 as our second point. And I'm finding the distance between those 2 points. So it's helpful to label these x1, y1, x2, y2. So when you're plugging into the formula, you can plug them, substitute them right in. So my x1 is going to be -3 minus x2 would be 2. And don't forget to square that. Plus y1 is going to be -1 minus y2 is 3. And I square that. So I've got the square root of -3 minus 2 will be -5 squared plus -4 squared. Now be careful here. If you're using a calculator, make sure you use the parentheses, because if you just plug in -5 squared into your calculator, it doesn't square the negative, it just squares the 5. So it'll give you back -25, which you should know that -5 times -5 is going to give you a positive 25. So don't always trust your calculator, because a lot of times if you enter it wrong, it'll give you the wrong answer. So -4 squared is going to be positive 16, which gives us the square root of 41. Now 41 is not a perfect square, so I'm going to keep that as my answer. If it asks you to round at this point, then you would plug it into your calculator. So I just want to show you that if you did Pythagorean theorem, I've got a length of 1, 2, 3, 4 here, and a length of 1, 2, 3, 4, 5 here. So that would be a squared plus b squared equals c squared. 25 plus 16 equals c squared. So I've got 41 equals c squared, which is the same thing I got from the distance formula. Now, the reason why the formula is helpful is because if I gave you points that were off the graph, say I gave you points like 81, 99, and 108, 150, it would be really hard to graph that and draw your triangle. So the distance formula will work in those cases when you have something that's off your chart. Okay, after the distance formula, we've got the midpoint formula, and the midpoint formula is the middle of 2 points. So if you're finding the middle of 2 points, you're basically finding the average of the 2 points. So if I'm finding the midpoint of 2 points, I'm going to add the x coordinates and divide by 2. And then my y coordinate will be the average of the y coordinates, which means I add the y coordinates and divide by 2. So any points on that graph, if I call this x1, y1, and x2, y2, the average of those will give me the center or the midpoint of those 2 coordinates. So let's look at an example. Find the midpoint of the line segment with endpoints 7, -2, and 9, 5. So again, I'm going to label my points x1, y1, and x2, y2. So when I go to plug in my formula, I don't accidentally substitute in the wrong number. So I'm going to have 7 plus 9, my 2 x's, divided by 2, and then -2 plus 5 divided by 2. So that's going to give me 16 over 2 and 3 over 2, which 16 over 2 is 8, and then you can leave that as 3 halves, or you can rewrite it as 1/2. It's the same. So your midpoint between those 2 coordinates is 8 and 1.5. So here's another problem. It says the diameter of a circle has endpoints -1, -4, and 5, -4. Find the center of the circle. So even though it doesn't mention midpoint here, if you know what the diameter is and it asks for the center, you should realize that you're finding the midpoint, even though it doesn't mention it. So if I've got a circle, the diameter goes from edge to edge through the center. So if I have -1, -4 as one endpoint, and 5, -4 as my other endpoint, I've got a circle that, let's see how beautiful my circle is. Not bad. So I've got a circle there. I'm trying to find the center. Now this one's pretty easy. You can probably guess what the center's going to be, but let's do the midpoint formula anyway to find the center. We're going to have our x1, y1, x2, y2. So I've got -1 plus 5 divided by 2, and then -4 plus -4 divided by 2, which is going to give me 4 over 2 and -8 over 2, which is the coordinate 2, -4, which is 2, 1, 2, 3, 4, right where we thought it would be. So that was just an example where it doesn't specifically ask for midpoint, but if you draw a picture and understand what's going on, you can kind of relate and know that you need to find the midpoint. Okay, next we're going to talk about graphing linear equations with 2 variables. So on this one, we've got y equals -3x plus 3, and we're going to graph it by plotting points. So I've got this table here. If x is -6, I'm going to plug that in to my equation where my x is. So I've got -3 times -6, which is 18, plus 3 would be 21. And you're going to do that for the rest of them. You're going to have y equals -3 times -3 plus 3 is 12. Plug in 0 for x. We'll give you 3. I'm going to plug in 2. Oops. -3 times 2 plus 3 is going to be -6 plus 3 will be -3. And then if I plug in 5, I get -3 times 5 plus 3. That'll be a -15 plus 3 will give me a -12. So what I've got here is a set of points. I've got -6, 21. I've got -3, 12. I've got 0, 3. I've got 2, -3. And I've got 5, -12. So just from the graph that I have, the 2 that will be on there would be 0, 3, and 2, -3. And really, for a line, you only need 2 points. So if I'm graphing this, I'm just going to graph 0, 3. And 2, -3. And that will give me the line -3x plus 3. Next, we're going to talk about intercepts. Intercepts are where the graph crosses the x or y axis. So let's think about this for a minute. Let's talk about x-intercepts first. So x-intercepts are going to be where the graph crosses the x-axis. So if I plot any point on the x-axis, let's say this point, that's the point 1, 0. If I plot this point, that's 1, 2, 3, 4, 5, 5, 0. If I go over here, that's -4, 0. So if you notice, all of these points, your y equals 0. That's the common thing. Anywhere on the x-axis, your y is going to be 0. So that is going to be how you find x-intercepts. You're going to set y equal to 0 and solve for x. Now, y-intercepts are just the opposite. If you're anywhere on the y-axis, any coordinate on here, the x is going to equal 0. So, for example, I want to find the intercepts of -x plus 5y equals -5. So if I want to find the x-intercepts, I'm going to set y equal to 0. So I've got -x plus 5 times 0 equals -5. So plugging straight into our equation here. And what's going to happen, any term that's with a y is going to go to 0, which will leave me -x equals -5. And then I'm going to divide by -1 to get x by itself. So x equals +5. So my x-intercept is 5, 0. Now my y-intercept, instead of setting y equal to 0, we're going to set x equal to 0. So I've got negative 0 plus 5y equals negative 5. And again, anything with an x is going to go to 0, which leaves me with 5y equals negative 5. And then divide both sides by 5 to get y by itself, and you end up with y equals negative 1. So your y-intercept is going to be 0 for the x, and negative 1 is your y. So now you can graph it from these 2 points, your 5, 0, and your 0, negative 1. So I've got 1, 2, 3, 4, 5, 0, and 0, negative 1. And that's the graph of that line. Okay, let's do one more. Finding the intercepts and graph the line. So let's look at x-intercepts. Again, you're going to set y equal to 0. So I've got 0 equals negative 2/3 x minus 4/3. And you want to get x by itself. So I'm going to add 4/3 to both sides. So it'll cancel on that side and move to the other side. So I've got 4/3 equals negative 2/3 x. I want to isolate the x. So I'm going to divide by negative 2/3. So x will be by itself and leaves me with x equals 4/3 divided by negative 2/3. Now when you divide a fraction by a fraction or divide anything by a fraction, remember the keep it, change it, flip it. That means you're going to keep the top, change the division to a multiplication, and flip the bottom. So you're going to have 4/3 times negative 3/2 when you flip the bottom. So you're going to multiply across. 4 times negative 3 is negative 12. And then the denominators, 3 times 2 is 6. So I've got negative 2 equals x. So our x-intercept is negative 2, 0. Now that's the hard one. The y-intercept's a lot easier in this case. Remember, we're setting x equal to 0 for the y-intercept. So just remember, you set the opposite variable equal to 0 to find intercepts. So this one's not too bad, because when I multiply 2/3 times 0, that's going to go away and leave you with y equals negative 4/3. So your y-intercept is 0, negative 4/3. So our two intercepts are negative 2, 0. And then 4/3 is like 1 1/3. And we're going negative, so we'll be down 1 1/3. So the graph of our line looks like something like that. Okay, and that is section 1.1.